Hey everyone, welcome to the third episode of CodeCrewTV. This episode is called Dancing and Debugging. Our main lesson is going to be all about finding and fixing errors in our programs, because as humans, making errors is inevitable. It's just part of being a person. So first, we're going to go over today's vocabulary. Then we're going to meet a local tech professional named Audra Willis, who is a co-founder of CodeCrew and the manager of innovation and performance analysis for Shelby County. We're also going to check out a demonstration of a game that I made on code.org. And we're also going to see an unplugged computer science activity that you can do at home without any technology at all. So keep in mind that you can access all of the digital resources that we use in this episode on our website, which is CodeCrewTV. And you can access that by either typing it into your browser or by scanning the QR code that we have right here on the screen. And you should be able to do pretty much everything that we do on Scratch on a laptop, on a tablet, on a phone. Scratch is the platform that we're using to learn all of our stuff, and it's very accessible. So next up, Maddie is going to tell us all about the vocabulary we're going to cover in today's episode.
Hi everyone, I hope you're excited about today's lesson on Scratch. Before we get started, here are some words you'll need to know. The first word is iteration. An iteration is when a set of instructions are repeated in a sequence a specific number of times or until the condition is met. The second word is debugging. Debugging is the process of detecting and removing existing or potential errors in a software code that can cause it to crash or behave unexpectedly. Now we have the term sequence. A sequence is a set of logical steps executed in order. Iterations use a sequence to repeat a set of instructions. The last word is sprite. A sprite is a static image or animated graphic designed to be a part of a larger screen. You will see an example of this during our lesson on Scratch. Now that you're all caught up, let's get started.
All right, welcome back. It is time for us to jump into code. So we are on the Scratch website right now. And as we know, our episode title is Dancing and Debugging. So debugging is finding and fixing errors in our code. And that's what we're going to do right now. So we have a task before us. Our instructions are right here. So it says when the green flag is clicked, both Gobo and Scratch Cat should start dancing, but only Scratch Cat starts dancing. So how do we fix the problem? All right, so let's take a look. The first thing we want to do is make sure that we are logged on to Scratch. So we are indeed logged on. It says CodeCrewTV right here. So you can find our classroom on Scratch if you go to our website, which again is CodeCrew.tv. You can also find links to all of our social media on there as well. So on CodeCrew.tv, you can find the link to our classroom. You can join there, and you can sign up for Scratch there as well. All right, so here we are. We have this starter project, and we're gonna remix it because remixing allows us to create our own version of this project, so that we can work on it. All right, so let's take a look here. We know that both of these characters are supposed to start dancing when we hit the green flag. But I don't think that's what's actually going to happen. So I'm going to go ahead and hit that green flag, and let's see what we get. So this is Dance Party, and I do see Scratch Cat dancing. Cat says it's fun. But I don't see Gobo playing along. So let's figure out why that is. All right, so the first thing that I would think to look for is what code is actually making Scratch move. All right, if we want Gobo to do the same thing as Scratch, first we have to have an understanding of what Scratch is doing, right? So we can see just by clicking the green flag, we can get an idea of what he does. Let's dive into the code though. So if I want to see the code that is controlling Scratch Cat, I select the sprite right here in my sprite section, and that will show me the code. So this says when the green flag is clicked, say Dance Party. All right, he does that, and then 10 times he does this stuff. So this is a repeat block. All right, and we iterate over the instructions inside of this repeat block. So this is not a forever block, which we saw last week. This is a repeat block, so it happens 10 times. So Scratch Cat is turning 15 degrees to the right, or clockwise, I guess, and then waiting 0.2 seconds, and then turning 15 degrees counterclockwise, and then waiting 0.2 seconds. And then that's happening over and over and over again until it happens 10 times. After that, we see that Scratch says fun for 1 second, and then we do 10 iterations of these instructions. So again, we're turning 15 degrees clockwise, we are waiting 0.2 seconds, and then we are turning 15 degrees counterclockwise and waiting 0.2 seconds. So this code looks pretty straightforward. I think we can look at it and understand why Scratch is doing the things that Scratch is doing, but we don't really know why Gobo isn't doing anything yet. So what I want to do is I want to dive into Gobo's code, which I can do by going down into my sprite section right here and selecting Gobo. And I can take a look at the code that is controlling Gobo. So this looks really familiar. All right, this is looking very similar to what we saw Scratch Cat doing. But for some reason, we know that Gobo is not actually dancing. Gobo is not saying dance party. Gobo is not saying fun. All right. So let's figure out why that is. So let's look at some of the similarities and differences between Scratch's code and Gobo's code. All right. If I look over here, sometimes the best idea is to just start from the top. All right, let's compare line by line. So here we're looking at Scratch's code right here, and we get extra validation that we're looking at Scratch's code because Scratch appears right here in our work area. All right, so I can see that the first line of code here is when the green flag is clicked. So now we're going to look at Gobo, and we're going to compare the two, and we're going to see if Gobo has that as well. So I'm going to click over here. And our first line of code over here is say dance party for 2 seconds. So that's a pretty major difference. All right, so let's start there. Let's add a when green flag is clicked block to this section, and let's test it. All right, so that when block, when green flag is clicked block, that is an event. And an event is just anything that your user does, or the person who is actually interacting with your program. Anything that person does is an event. All right, so when they click on the green flag, that's an event. and let's test it, okay? So I'm going to hit the green button, and I'm going to make a prediction now, all right? Because when we test, making predictions makes our tests more meaningful. All right, because if I am just throwing code into my workspace and I'm not thinking about what that code is actually going to do, I'm not really doing myself any favors, right? I'm just kind of like throwing stuff at the wall to see what sticks. And sometimes it can be really frustrating to go through this step and make yourself stop and think about what you're expecting your code to do. Because if you're like me, you really, really, really just want to see it happen. But I have learned many times the hard way that usually that just ends in frustration and a lot of wasted time that could be spent on something else. So, all right, so we're going to make a prediction. My prediction is that when we click the green flag, both of our characters are going to follow the instructions that are on the screen. All right, that's my prediction. Now that we have a prediction, we'll know whether or not our code was successful. All right, so let's go ahead and hit go. All right, it's looking good so far. Both of them are dancing. Both of them said dance party. Both of them said fun. So let's see. All right, I'm going to call this a success because my prediction was that they would both dance, they would both follow the instructions, and they did. So I feel pretty good about this. All right, so we are going to pause here. All right, we're going to go on to our next segment, which is we are going to meet Audra Willis and find out who she is, what she does in Shelby County, and hear a little bit about her background. All right, so after this short break, we'll be back to do some more code.
Good morning, students, and welcome to CodeCrew on SES TV. My name is Audra Willis, and I am one of the co-founders of CodeCrew, and I also had the privilege of serving as the Manager of Innovation and Performance Analysis for Shelby County Government. So let's talk about how did I get my start in tech. So a long time ago, before Facebook, before TikTok, there was this thing called MySpace. And so I would spend a lot of time trying to update my profile. And at the time, MySpace would allow you to change different things on your profile. And it was set up kind of like what you guys know to be just a plain old website. And so you could go in and you could take HTML tags and CSS tags, which are markup languages for coding, and you could go in and you could change up what your profile page looked like. Well, that was a long time ago, and I remember my boss came and he said, "What are you doing?" And I said, "Well, I'm updating my MySpace page," and he let me know then that what I was doing was something that was actually needed in the company, and I worked for TSA at the time. So he took the initiative and he saw something in me, and he introduced me to the IT team, and from there they taught me everything that I was able to learn, and I soaked up as much as possible within that time frame. And I took all that knowledge and I scored my first job as a web developer. One thing I love about CodeCrew and being one of the co-founders is being able to work and interact with students like you. I'm a native Memphian, so it's a privilege and an honor to represent you guys in the tech space and let you know that anything that you desire to do within the tech space is tangible. And at CodeCrew, we're here to support you in those efforts and to ensure and facilitate that you're all are able to achieve those goals. We have everything from hackathons to after-school programs that you can get involved in. Here at Shelby County Government, I'm able to use my tech skills to service the county in innovation and performance analysis. So a lot of things are happening now, and of course you guys know you're out of school due to COVID, but one of my one of my tasks here at Shelby County government is to ensure that the mayor has all the data he needs to be able to report and communicate to constituents and citizens the health of the city, the health of the economy, how we're getting back to business and normal. And so every day I come to work and I get tons of data, and I have to dispel between what's usable, what's not usable, what we can do to relay this information. I take data from the health department and community services, and I layer them on top of each other to get sources of the truth on how we're able to help citizens and get COVID testing out faster. So it's just a plethora of things that we do here at the county in terms of data. The really important things that I've been working on since COVID-19 happened here at the county is creating different types of maps and databases so we know where the help's needed throughout the county. So take for instance one of these things, somebody sent me over 4,000 addresses of individuals within our county that needs help. So what I was able to do was create heat maps and what we refer to as cluster maps, so that those individuals making decisions would be able to better visualize where help's needed the most. So a lot of my job is making sure that citizens are taken care of and individuals that are making decisions have the best information that they need.
Welcome back, friends. I'm so glad that Audrey could fit us into her schedule because she is a vital part of Code Crew. We would not be here without her, and she does so many amazing things. Every time I talk to her, she is doing more cool stuff. So she's really into virtual reality lately. So later on, in another episode, we're going to get to see some examples of some really cool VR demos that she's going to put together for us. And we're also really grateful for that. So, all right, we have a new challenge before us. All right, so this is our second debugging challenge. We have another broken program that we're going to try to deconstruct and figure out what's going wrong and fix it. All right, so let's read our instructions here. It says, in this project, when the green flag is clicked, the scratch cat should start on the left side of the stage, say something about being on the left side, glide to the right side of the stage, and say something about being on the right side. It works the first time the green flag is clicked, but not again. So how do we fix the program? Well, let's dive in. The first thing we're going to do is remix it. All right, remixing it gives us our own copy. And now let's kind of see what's going on. So looks like we've got some extra stuff on here. We've got Giga. Giga looks pretty cool. But we're going to focus on Scratch Cat right now. So let's test it. Let's go ahead and hit the green button. So Scratch says, I like the left side. Then we go to the right and says, I like the right side too. All right, so that worked. All right, let's try it again. So Scratch says that they like the left side, but they were still on the right side. And then there was no gliding. All right, so I think we have identified what needs to be fixed. Let's figure out why it's not working the way we want it to work. So first, the first thing I like to do is just jump into the code and get an idea of how it's doing what it's doing. So we see that we have our when green flag is clicked. That's going to kick everything off. All right. Then we have our say block, our glide block, and our say block. So, and let's take a peek. There's some other code in here, but I think this is going to be for later stuff. So we're not going to worry about that right now. All right. So our glide block moves us to x equals 120. All right, so those of you who are a little bit older, maybe in 8th, 9th grade, you should be pretty familiar with X and Y coordinates. But if you've never seen these before, X is basically the distance from the left side of the screen, and Y is the distance from the bottom of the screen. All right, so this is measured in pixels, which are like teeny tiny little lights that are in your screen, no matter what device you're using, whether it's a phone, tablet, computer, desktop, laptop, doesn't matter. It's all pixels. So right now we are gliding 120 pixels. Oh no, I'm sorry. We are gliding to X equals 120. All right, that's different. So no matter what, no matter where we start, we are always going to glide to X equals 120. All right, and we can see that it's telling us that X equals 120 right where Scratch Cat is. And if I move Scratch Cat around, it's telling us different coordinates here. All right, but I'm going to refresh this page just so that we start fresh. All right, so once again, we hit the green flag. It works properly. And then the second time, it does not work properly. So I'm wondering if that has something to do with the fact that Scratch just stays where they are. So Scratch is not ever being reset. Their position is never being reset. So when we start again, our say block runs perfectly, but then we're telling it to glide to X equals 120. Well, we can see that Scratch already is at X equals 120. So there's no gliding to be done, right? So we can prove to ourselves there's no gliding to be done. So I think what we want to do is we probably want to tell Scratch to like go back, right? So when we click on the green flag, we want to tell Scratch where to start. Otherwise, Scratch is always going to be at X equals 120 after the first time we run this program. So let's see. So how am I going to reset Scratch's position? All right, well, that has to do with motion. All right, so we're going to be working with the blue blocks. All right, and I'm pretty sure that I just need something similar to this one right here. But I don't really want to glide at the beginning. So let's see what that would look like. So let's say that I pick the glide block. Because I see a glide block here. Looks like maybe that's what I should do. All right, I'm going to change this to X is 0. And let's test this. Let's see what Scratch does. All right, so Scratch does go back to the left side. But I feel like Scratch is doing more than we intended for them to do. All right, we really just want them to start at a certain position and go from there. Now, if we want to find out where Scratch started at the very beginning, we can refresh again. And we will double check our X position right here. So actually, we want to set Scratch to X equals -39. All right, if Scratch is going to go back to where he was. So I'm actually going to say maybe Scratch should be a little bit further to the left. And you know what? I'm also going to remove our friend Giga, because I think Giga is just kind of confusing matters. It's not personal. All right, so we want Scratch to reset to this position now, and we can see that X equals -167. So let's test our code. Let's see what it does. So we like the left side. We like the right side. Hit the green one. Scratch doesn't go back. All right. So I actually forgot to save my progress before I reloaded my page. So this is a good lesson for everyone. Make sure you save your progress before you reload your page. Otherwise, it will throw out any changes that you made. All right. So what we had was the glide block, but glide was doing too much. All right. I'm thinking that we really just need to tell Scratch to go back to a specific location. All right. We want it to happen immediately at the start of our code. And that is where I'm pretty sure this go to block is going to come into play. All right. So if you recall, our initial X position, our starting X position was negative 167. All right. So let's see. Scratch, my prediction, again, is that Scratch is going to go back to their starting point and then say, I like the left side, glide to X equals 120, and say, I like the right side too. All right. So let's test it. This is promising. This is very promising. All right. So let's test it one more time. Let's make sure that Scratch starts on the left side and then glides to the right. Cool. All right. So again, we made a prediction so that our test was meaningful. All right. The prediction makes our test meaningful because then we have a way to gauge whether or not we were successful. All right. And now we can see that we were successful. So, all right. I feel pretty good about this. All right. I feel great about the fact that we got Scratch from one side of the screen to the other and then back again. That's pretty good. All right. So we are going to pause here. We are going to move on to our next segment, which is a tech demo. All right. I am going to show everybody a game that I made. It's a little silly. But I think it's a lot of fun, and I will even put a link to it in on our website on CodeCrewTV. You'll be able to play it on any device you want to. You could even remix it and put your own spin on it, and I would encourage you to do so. All right, so that's what's coming up next. Welcome to the tech demo. So this is a game that I created in code.org, which has a lot of similarities to Scratch, which I think you'll see more of once we take a look at the code. So your goal in this game is to collect as many rainbows as possible. And so hitting this alien currently does not hurt you in any way. The alien just acts as an obstacle. So the alien, as you can see, the alien collides with the rainbow, and the alien also bounces off of the sides here. So there isn't a huge difficulty curve to the game, and I think that is an opportunity. There we go. Okay, we did get a game over because we lost all of our lives. So that's an opportunity for y'all out there to remix this and add your own spin to it. So this is controlled just with the up and down keys. That makes Nyan Cat go up and down. And then I shoot these little lasers with the space bar. We're going to take a short tour of the code here. So if you go to this link, which I'm going to put on CodeCrew.tv, you can view the code. All right, and because this is my project, I can actually edit this code, but if you want to edit it, you'll just go ahead here and remix it. So you can see that there are some similarities between Scratch and code.org. We're working with sprites here, which we know sprites are a graphical character on the screen that we can control with its behavior or its appearance with our code. We have blocks, just like Scratch does. One difference is that we can go to show text, and we can actually see the text that the blocks creates, which is kind of cool. Let's go back to blocks, though. I like the blocks. They're colorful. Makes me happy. So I'll show you. So creating this game, the way that it works right now, it took quite a bit of code, but that's nothing to be afraid of. I used to think there's no way that I could write a program that has dozens of lines of code or hundreds of lines of code, or, I thought I would never be able to do something like that. And I learned two things about that. One is that, yes, I can. And then the other is that the quality of your program is not determined by the length of your code. All right, so even super short programs can be really awesome. In fact, there is an old programming adage that the best code is no code, because only no code can have no errors. And that seems appropriate for today's episode, which is all about debugging and finding errors. So I challenge those of you who are out there to go ahead and remix this. Even if this code doesn't make sense to you, one of my favorite learning strategies is just to take something that already exists and just change some stuff. If you remix this, there's nothing that says that you can't change this number right here, right? There's nothing that says you can't change this number right here. So change some stuff and see what happens. That's one of the best ways to learn, is just take something that already works, change things, and observe. And don't forget to make a prediction about what you think is going to happen when you change something, because predictions make our tests more meaningful. All right, so that's really all I wanted to show everyone of this game. It is not a perfect thing. So if you have ways that you can think of to improve it, I challenge you to do so. All right, I would love to see what everyone can come up with. All right, so we are on our final challenge of the episode. So we have some more debugging to do. Let's read our instructions. It says the Scratch Cat should do a flip when the space key is pressed, but when the space key is pressed, nothing happens. How do we fix the program? So let's remix. Let's take a look. So we will run our code, and it says that when we hit the space bar, Scratch should do a flip. I'm going to hit that space bar, and it looks like nothing happened, right? I'm hitting it a couple more times, and it looks like nothing is happening. So before, one of the problems that we ran into is that we weren't listening for the right event. We weren't listening for the user to hit this green flag up here, but we actually are listening to our intended event, because we do have a block here that says when space key is pressed. And let me zoom in. This is kind of small, isn't it? Let me zoom in. There we go. All right. So when space key is pressed, we turn 90 degrees, and then we turn 90 degrees again and again and again. All right. So we know that there are 360 degrees in a circle. So if we turn 90 degrees 4 times, that should bring us back in the original position, right? So we should kind of go in this loop, but that's not happening. So this is a strange one, all right? Because the code is very simple, and it looks like everything should be working properly, right? And also, there's no way to tell just from running it whether anything is happening because the result looks exactly like the beginning, right? So Scratch starts and they are standing straight up. And after doing 4 90-degree turns, Scratch would be standing straight up again. So it may be that this code is actually doing something and we're just not seeing it. So the first test that I'm going to do is I'm actually going to remove one of these blocks. All right, let's take this over here, get rid of it. And let's run our program. So I'm going to hit the space bar. Okay, so this is very interesting. All right, this is very interesting because now we have turned a certain number of degrees. We've turned 90 degrees 3 times, which gives us 270 degrees. So it makes sense that Scratch wouldn't quite be back to their original orientation. So what that means is that it actually was doing stuff before. It actually was running all of our lines of code before. They just happened really, really fast. So let's go ahead and let's put our last 90-degree turn in. All right, let's put this back. So what's something that we could do that would show us that Scratch is actually spinning or doing a flip? So we've seen some blocks before that say wait. All right, so we can tell Scratch to wait a certain amount of time in between each turn. So let's try that. Let's see what happens if we grab a wait 1 seconds block. All right, I'm gonna do that, do that, do that. And let's put one, oops. I don't know where that one went. It vanished. Let's put one down there for good measure. All right, so I am going to reorient Scratch because we want Scratch to be facing to the right to start with. So let's see what happens. All right, so I am going to hit the space bar and check it out. So what we're seeing here is that our code actually was doing exactly what we wanted it to do. It was just doing it so fast that we couldn't see it. And that's an interesting thing about computers. A lot of times we think that computers are so much smarter than people, right? Computers can do stuff that humans can't do. But a lot of times computers just do the same stuff that humans do. They just do it really, 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 really fast. So sometimes it's hard to tell whether the error is in your code because you put the wrong code in, or maybe the computer is just running so fast that you weren't able to see all the steps taking place. So let's run this one more time. So I'm going to say this is a little on the slow side. I think that Scratch can probably be a little more acrobatic. Pardon me. So I am going to shorten this. So I'm going to make Scratch wait half a second or 0.5 seconds in between each. All right, let's test this. I'm going to hit the space bar. All right, that's more like it. I think we can probably go even a little bit more faster, some might say. We're going to go with 0.1. That is 1/10 of a second. So this is faster, but I think it's still going to be at a reasonable enough speed that we will be able to witness it. Look at that. That is a good looking flip. All right. So this was our final challenge of the day, but this is not the last debugging challenge. Okay. There are 2 more debugging challenges awaiting you, and I will link to them on CodeCrew.tv. So go ahead and pull up CodeCrew.tv, check out those challenges, and see what you can do. All right. So we are actually going to be hosting some office hours on Friday, May 15th. All right, where you can actually talk to us, ask us questions. So if you are testing out the code and something's not working quite right, you can come to our office hours on Friday the 15th and find out why. Find out why your code's not working. All right. So go ahead, give these challenges a shot. Go to CodeCrewTV, check them out, and we will see you on Friday. All right. So next up, we have an unplugged activity that you can do without any technology. All right, you can do this at home probably right now. All right, and that's coming up next.
Hi everyone, my name is Brittany Smith. I'm one of the CodeCrew CAs, and today's unplugged activity is going to be about algorithm. What's an algorithm? An algorithm is a set of instructions that you use to complete a task. Simple tasks such as your daily morning routine for going to school or work consist of smaller tasks like brushing your teeth, grooming your hair, and putting on your attire. An algorithm has three major components: input, process, and output. Input will consist of your materials that you need to complete the task. Process will be the steps that you take to complete the task. And output will be the results of the task that you completed. Today's algorithm is going to be about washing your hands. For this activity, you will need warm running water, soap, and a towel or paper towel, whichever one you prefer. So let's get started. First, we're going to turn on the water. And we're going to let the water warm up to the desired temperature that you would like. Since my water was already turned on previous to the video, it's already to the desired temperature I would like. We're going to place our hands under the water and let our hands get completely wet. Once your hands are completely wet, we're going to add soap. You can have liquid soap or bar soap. Make sure you rinse your wrist between your fingers and under your nail again. Now that all the soap are gone off your hands, you should grab your towel or a piece of paper towel to dry them completely off. Once you finish drying off your hands, turn the water off with your towel or your paper towel and properly dispose your paper towel if you use them. Now guess what? Not only do we have clean hands, but we also created an algorithm. Our input consisted of water, soap, and paper towel, and the instructions that we followed were part of the process, and as a result, we have clean washed hands for our output. So today, not only do we have clean washed hands, but we also created an algorithm. Thank you for attending the Unplugged activity today. I'm Brittany Smith, CodeCrew CA.
All right, so that wraps up our show for today. Thank you so much for watching. We are so happy to have you all watching with us. So please visit our links. All of our social media links are on the screen along with our website, which is CodeCrewTV. And also, if you're able, please join us for office hours on Friday, May 15th. So we will be posting the link to the office hours on CodeCrew.tv. All right. So once again, thank you so much for spending this time with us, and we will see you next time.